So now we are going to learn about understandability. So a software is understandable if it is easy for developers to understand the produced artifacts. So if we just keep it simple, it's actually expresses the clarity of the system design. So if the system is well designed, suppose they have used strong software engineering practices, they have used object oriented or component based techniques, then it's a well designed system. And as new developers join the project, they are able to understand easily the implementation details, and then they can quickly begin contributing to the project. So that's why understandability is really important in product quality. And it can be enhanced by modularity, discipline, and standards. Modularity is actually logical partitioning. It's actually logical partitioning of the software design, and it allows complex software to be manageable. So if your software is manageable, then it's easy to understand. So that's why it will enhance understandability. And also if you apply discipline or standards, it will be easy for developers to understand, and they can quickly begin contributing to the project. Verifiability. Verifiability of software is how easy it is to check your code for bugs. It actually plays an important role in testing, because you cannot test something properly if it is difficult to verify that it's correct or it's not correct, right? So that's why verifiability is important in testing, and also it's important in debugging process. And also it could be improved by monitoring the desired properties, and it could be enhanced by modularity, discipline, and standards. So in the previous slide we have seen that if we apply modularity, discipline, standards, it will enhance understandability. So verifiability is affected by understandability as well as reliability and visibility. Maintainability. We have talked a lot about maintainability, right? Software is maintainable if it can be modified easily after a version release. So the main thing is if your software can be modified easily. Suppose you build a valuable product that works perfectly, but it's difficult to modify and it's difficult to adapt to new requirements. Then what do you think? Will it survive in today's market? I don't think so. So that's why maintainability in a long term is a long-term aspect that describes how easily software can evolve and change, which is especially important in today's agile environment. Suppose talk about a bad code. Okay, so if you write a bad code, that bad code requires a larger effort and cost more to adapt to new requirements. And if you write a high quality code that is readable and well documented, then the software is more easily maintainable. So keep good coding practices in mind while your software is still in development. And this maintenance actually costs 60% of total software costs. We have learned this in chapter 1, right? So here there are lots of maintenance: corrective maintenance, adaptive maintenance, perfective maintenance, and there is one more, preventive maintenance. So corrective maintenance is actually related with the detection and correction of faults, and adaptive maintenance, it's actually related with the changes to the software that keep it compatible with the changing software environments such as hardware and operating system. And perfective maintenance is actually concerned with improving system functionalities.